When we're working with composite trig functions, where our inverse trig piece is inside of the parentheses, or the first part of what we're going to do, there's only really one question we have to ask ourselves, and that is this value, is our x value in the domain of that inverse? If it is, we just cancel things out, and that's our answer. If it's not, our answer is undefined. So recall that the domain of the inverse sine function is between -1 and +1. And I'm referring to this chart here, if you recall these. So there's our domains of our inverse trig functions. So sine was -1 to 1, same with cosine, tangent was -infinity to +infinity. So anyway, I would have that chart handy as I do these problems. So anyway, back to what we were doing. So is 0.8 in between -1 and 1? And yes, it is. So if that's the case, if it's in our domain, the problem is as easy as canceling these things out. Sine of the inverse sine cancels out, and so the answer is just 0.8. We can verify this very easily using a calculator down here. I won't show you that part, but I would encourage you to try that on your own. Just type in sine of the inverse sine of 0.8 and make sure that, yeah, it is 0.8. Next up, I have the cosine of the inverse cosine of pi. Well, once again, the only question you really have to ask yourself is that in our domain? Our domain for inverse cosine is, again, -1 to +1. Pi, sadly, does not fit in between there. So pi is not in the domain, which means these don't just cancel out. Instead, we can't even do the problem. There is no answer to this problem. The answer is it's undefined. And again, you can verify that very easily using your calculator. Type in cosine of the inverse cosine of pi, and you'll get an error message. You can't do it. Okay? Last up, we have the tangent of the inverse tangent of -5/3. Again, the only question we need to ask ourselves is that x value in our domain? And, well, the domain of the inverse tangent is everything. So inverse tangent, when it's on the inside, will always work. If you didn't know what this decimal was, which I'm guessing you don't, and you needed to know, then just use a calculator and find out what that decimal is. But again, because everything for inverse tangent works, this is in the domain, which means it's as simple as canceling those out, and my answer is just what's left over, -5/3. And again, you can verify that fairly easily using your calculator. You probably want to get the decimal equivalent of this to check that on your calculator, but it'll check out just fine.